In these next couple of sections, we're going to dig a little bit deeper into some of the parent functions that we've been studying a little bit more generally. So we've already talked a lot about linear functions in our previous classes. So we're going to talk first about the absolute value function. And so we know that the absolute value function is y equals the absolute value of x. And so the parent function of the absolute value of x we've seen looks like a V shape. And here's what the table of values looks like. We've seen that the domain is all real numbers, and that's because when we look at the graph, we move from left to right and we run into arrows on both sides of the graph, but the range is only y greater than or equal to 0. And then the vertex, this is vocabulary that might be new, the bottom of the V shape, this point on the graph, that is called the vertex of the absolute value graph. And then the axis of symmetry is this invisible line. So when we draw it kind of as a dotted line. This invisible line that shows where the symmetry happens, it's kind of like this imaginary line that if I were to fold the absolute value in half, that's where it would match, almost like a butterfly when it folds its wings. So it is symmetric across that line. It's a reflection across that line. Every point is a reflection across this absolute symmetry, or axis of symmetry there, okay? And then another characteristic, which might be kind of a new one to talk about, is this idea of increasing and decreasing. Now, I know you talk about this a little bit in Algebra 1. Increasing and decreasing, we always read a graph from left to right. So we're talking about across the x-axis. If I move from left to right, imagine kind of like a little roller coaster as you're riding. As I ride from left to right, this roller coaster is going to be going downhill as I approach from the left of 0. And then when I hit 0 here, then the roller coaster will be going uphill there. And so this is actually a typo right here, so we need to fix this in our notes. The graph is increasing to the right of 0, so it's increasing when I'm on the side of the graph where x is greater than 0, and it's decreasing where I'm on the side of the graph where x is less than 0. That's the idea of increasing and decreasing. We always talk in terms of x values because we read a graph from left to right, okay? Now, as we've seen, that's just the parent function. I can stretch, shrink, translate, reflect. We can do all sorts of things to this graph, and that creates a new function. So a stretch or a shrink is going to change the steepness of the sides, which are basically two lines put together. A vertical reflection will flip the graph upside down, and a translation will move the vertex. So we can consider these transformations to give us this graphing form of an absolute value function. And so based on what we know about the transformations, we can predict some of the characteristics. Okay, we know that HK causes a translation, and so that's going to tell us where the new vertex is going to be, which kind of makes sense. If I know that the vertex starts at 0, 0 for the parent function, and let's say that I move it to the right 2 and up 3, it makes sense that my new vertex is going to end up at 2, 3. Or if I move it to the left 2 and up 2, it makes sense my new vertex is going to end up at negative 2, 2. And so that's why HK is going to end up being the new vertex. Now, here's what's really important. We've talked about this several times before. The negative in front of the H in the formula tells us that this is going to be the opposite sign. And that's not a new idea. We've seen that with the transformations. If I have something like x plus 2, that means I go to the left 2. That also means that the value of H would be negative 2, not positive 2. So we always have to flip H. K is always going to stay the same. I remember K for keep. Keep the K, flip the H. And then axis of symmetry, remember that's that vertical line. Axis of symmetry is the line x equals h. Now remember we talked about vertical and horizontal lines, hoi vux, vertical, undefined slope, x equals equation, and it's always going to be x equals the x coordinate of the ordered pair. Well, the x coordinate of the ordered pair is h, so that's why it's going to be x equals h. And then the value of a is going to represent the slope of the right-hand side. So again, since the absolute value graph has straight sides, we can count rise over run, up 1 over 1, up 1 over 1, just like that. But then it goes backwards on the other side, up 1, backwards 1, up 1, backwards 1. And so that's how we're going to be able to figure out what the sides do, okay? So let's go ahead and sketch a couple graphs. So we want to graph the function, give the vertex, domain, range, and intervals of increase and decrease. And I'm going to add to that axis of symmetry, even though it didn't ask for it. So number 1 says y equals the absolute value, or -3 times the absolute value of x. So the first thing I notice is this -3. That's the value of a. So a is equal to -3. I don't have anything plus or minus the x on the inside, so that tells me that h is 0. I also don't have anything plus or minus on the outside of the absolute value, so that also tells me that k is 0. So what do I know then? I know that my vertex is 0, 0, because my h and k are 0, 0. I also know that my axis of symmetry is going to be x equals 0. Again, you always have to have the x equals because it's the equation of a vertical line, and then it's always going to equal the x coordinate. Always, okay? So I start by plotting my vertex, which is 0, 0. Now, 2 things that I should know. 1, I should know this is going to be upside down because the negative tells me this is a reflection over the x-axis. 2, I should know that this should be a skinnier absolute value because that 3 says I have a vertical stretch. So a is the slope of the right-hand side. So that's -3. So that tells me I'm going to go down 3 over 1, down 3 over 1. So there's one side. And then I'm going to reset to my vertex, and I'm going to go backwards. Down 3, backwards 1. Down 3, backwards 1. And so there's the V shape of my graph, which is exactly what I thought it was going to look like, upside down and skinnier. And now by looking at this, I can see the domain is always going to be the same. It's going to be all real numbers. I can see the range now, because it's upside down, is going to be y is less than or equal to 0. And then again, if we read our graph from left to right, we're going to be going up the hill and then down the hill. So I increase first when x is less than 0, and I decrease when x is greater than 0. First we go up the hill, then we go down the hill. Increase, then decrease, and it changes right here at x equals 0. Okay? That's all there is to it. 2 straight sides, and there we go. So let's try another one. So in this case, a is equal to 1. That's because there's nothing in front. It can't be 0. If I multiplied by 0, that would zero out the whole thing, and I would just have y equals 0. There would be no absolute value left. So a is equal to 1. H is equal to -4. Remember, this always has to be the opposite. And then k, again, is equal to 0, just like it was on the other one, because there's nothing on the outside of the absolute value. So that tells me that my vertex is -4, 0. Now let's think about transformations. That would tell me that this moves to the left 4 and up none, so it should be here. And that's exactly where the point -4, 0 is. Now the slope of our sides is just 1. So I'm going to go up 1 over 1, up 1 over 1. I'll do that a few times. And then I go back to my vertex, and I go up 1, backwards 1. And I do that a few times. So there is my V shape. Remember to extend your graphs all the way to the edge. That was a crooked line. And there's our graph. Ta-da! No stretches or shrinks and no reflections. So that looks exactly like I want it to. So here we go. Axis of symmetry. X equals -4. Always x equals, and it should equal the x coordinate. Domain is always the same because there's arrows on the left and arrows on the right. And then range for this one is going to be y greater than or equal to 0. We didn't move it up or down, so that stays the same. This one decreases first, and it decreases until I get right here at x equals -4. So it decreases to the left of -4, and it increases to the right of -4. All right, I'd love for you to pause the video and try 3 and 4 on your own so that you can do a quick little brain check and see if you understand this. I'll come back with the answers to number 3 and 4 in just a couple of seconds. All right, here are what my graphs look like. So for number 3, a is equal to 2, h is 0, and k is -1, so your vertex is 0, -1. Your side should be a little bit steeper since that's a vertical stretch by 2, but it still opens up. And so that is the graph that you get. Now, number 4, we do have a reflection, so that one should open down. Your vertex is +1, +3. Remember to switch the h. And there's all the other information. So hopefully that helps you get started, and I'll see you back here next time.